unit. Does anyone know what rational means in terms of math? Not real. There's numbers that are real that are irrational. Anyone know what rational means? One to infinity, well, not infinity, but all the numbers that you count, those are rational. But numbers that you don't count can be rational too. Rational in math means fraction. So rational numbers are numbers that can be written as fractions. So this unit is the fraction unit. This is when we're working on fractions. So today we're going to be looking at a fraction where you just are looking at one fraction at a time, and we're going to look at how do you simplify one fraction at a time. Okay, when you have numbers and letters and things like that, and then when you have things that look like what we were just factoring, if you have an x squared plus an x plus a number, or if you have an x squared minus a number, like how do you simplify that if it's in fraction form and you have stuff on top and stuff on bottom? All right, so the first step, we have a 5-step process. Your first step is going to be to take the problem and write it as a fraction, numerator on top, denominator on bottom. Then you're going to write all the terms in descending order, which means you put the highest exponent first and you put the plain number last. Then you're going to go through and factor the problem, which is the most important part, is we write everything factored. If you have a negative in the front, you're going to put the -1 out in front. You're going to take a GCF of -1 out, put a star next to that, circle it, underline it, do something. This is super, super, super important. So in the past, if you didn't take a negative out, we'd say, well, yeah, it's more proper to take a negative out, but you're not wrong. But this unit, if you don't take the negative out, you'll actually get the problem wrong, or you might not notice what's happening. So take the negative out if the first term is negative, look for GCFs, look at difference of squares, think about trinomials, think about slide divide. Then you cancel out the factors that are the same on the top and the bottom, and then at the very end you have your simplified answer. All right, so the first type of problem we have is we have what are called monomials. They've got one term divided by one term, and these ones are pretty easy to do. 18 over 24, if we think about what number you could divide into 18 that you could also divide into 24, what would that be? What divides into 18 and 24? 6. So 18 divided by 6 is 3. 24 divided by 6 is 4. So we know that our answer is going to be 3 on the top, 4 on the bottom. And then on the top, we have x to the third, which is x, x, x. There's 3 of them. On the bottom, we have x squared. That means there's 2 of them. So 3x's on the top, 2x's on the bottom. 1x on the top would cancel with 1x on the bottom. And so if the top has an exponent that's bigger, that means the top is going to win. If the bottom has an exponent that's bigger, that means the bottom is going to win. And then you can basically just subtract your exponents. So 3 minus 2 is 1. That means we're going to have 1x left over on the top. So this is our final answer here. Okay, for example 2, if we walk our way through the steps, this problem is already written as numerator over denominator. I don't have to worry about the descending order because it's not written in this form. It has already skipped to step 3 where it's written in the factored form. So this has been factored. They took the GCFs out and then they wrote their leftover factors. Now I'm going to reduce the common factors. So x minus 1 and x minus 2, those parentheses are different, so I can't cancel my parentheses at all. They can only be canceled if they're identical. So I'm going to look at my GCFs. My GCF of 7 and my GCF of 3, those can't be reduced at all, so I can't do anything with those. But I have a GCF of x on the top and a GCF of x on the bottom, and I can cancel those GCFs. So x and x can cancel, and that leaves me with a 7 on the top and an x minus 1 on the top it leaves me with a 3 on the bottom and an x minus 2 on the bottom. And that's my final answer. Okay, example 3 says that it's a division problem, but it's not written as a fraction. So I'm going to look at step 1. Step 1 says to write this problem as numerator over denominator. So that's what I'm going to do first. Numerator, I've got x squared plus 9x plus 20. That's going to be on the top. Divided by x squared plus 13x plus 40. Now, you guys have seen the dead baby animal wall, and I haven't really done much with it this year. The most common dead baby animal is for this unit. It's where students skip from step 1 to step 4, and they try to cancel things without factoring. Okay? So if you are looking at this problem and you say, ooh, x squared and x squared, those cancel, right? The answer is wrong. They don't cancel because this is an addition problem. Addition and division are not opposites of each other. Does that make sense? Addition and division are not opposites of each other. So if you do this, you kill a cute little puppy. And if you do this on a sheet of paper and then turn it in, I will write down that you killed a puppy. And then I will put a sticky note on the little puppy. Where is it? The cute little puppy over there. I'll put a sticky note on that, and then I'll make you add a tally so we can keep track of how many puppies you guys kill. So we'll put a sticky note on it now so we can keep track this unit of how many puppies we kill. I just want you guys to appreciate how adorable, look at the puppy. Do you see? Look how cute the puppy is. If you make that mistake, the puppy dies. You guys see the puppy? Look how cute it is. You can smile. That's okay. The puppy's cute. So what mistake are we not going to make? We're not going to kill the puppy. We're not going to cancel before we factor. Look how cute the little puppy is. It's a cute little puppy. Okay. So we are not going to kill. We're not going to kill that cute little puppy. Look at his little face. Look at it and his little eyes. Don't kill him. So we can factor, we can cancel when they've been factored. We can cancel when they look like this. But we can't cancel when they look like that. See the difference? Okay? Here it's written as multiplication. And multiplication and division, those do cancel out. Here it's written as addition. Addition and division do not cancel out. See the difference? Okay. So let's do the problem the proper way without killing any puppies. So here we're going to walk through the steps. So the first step we already did, we wrote it as numerator over denominator. Second step is good. It's written in the correct order, descending order. The next step is to factor. So these are just those regular trinomials. So I'm going to look for what multiplies to 20 but adds to 9. And I'm going to look for what multiplies to 40 but adds to 13. So does anyone know what either of those should be? 5 and 4, 8 and 5. Okay, so we should have x plus 5, x plus 4 for the top, and then x plus 8, x plus 5 for the bottom. Okay. So we did step 1, step 2, step 3. Step 4 is we can reduce the factors that are in common. So we rewrote this as x plus 5 times x plus 4, x plus 8 times x plus 5. Now, since this is a division problem, we can cancel multiplication with division. Okay, so x plus 5 divided by x plus 5, that makes a 1. These cancel each other out. And then we can write the leftovers. We are left with an x plus 4 on the top and an x plus 8 on the bottom. And the x's cancel and I get 4 over 8, which is 1/2. No, that's dead puppies. I just told you how to kill a puppy and you just killed 2 puppies. No, we can't do this because these are different parentheses. You can't cancel those. They're different. Well, okay, so why can't we cancel these? Puppy killers. This is an addition problem. Addition problem. Division. Oh, okay. So don't try to kill the puppies. It's very tempting, though, isn't it? Okay, don't be weird. Don't be tempted to kill puppies. That's weird, man. Okay, so no killing puppies. You cancel out factors. You don't cancel out this stuff. Do you guys see the difference? Okay, these are whole sets of parentheses. Unless the whole set of parentheses is identical, you cannot cancel it out. See the difference? Okay, we're going to practice again, because that was 2 dead puppies. Don't worry, I revived them, you sickos. Okay, let's do the next problem. All right, so we got to rewrite this. First step, we got to rewrite it as numerator over denominator. Okay. Second step, it has to be written in the correct order. Is it currently written the way it should be? It is not. So how should I rewrite this? Minus 6x, perfect. And then on the bottom was good. Okay. And then once I have it rewritten in the correct order, now the next step is not to start canceling because that kills puppies. I don't cancel yet. I factor. What type of factoring do I have? GCF, yeah, greatest common factor. What is the GCF on the top? X, okay, so I'm going to take an X out, and then what is left over? So take out the X. I agree with the minus 6. X squared is what I should have here, okay. And then on the bottom, what type of factoring do we have? GCF again. I take out the X. What's left over? X plus 1. Okay, so we always, if we have 2 terms here and we take a GCF out, we have to have 2 terms left over in our parentheses. And since this was identical with our GCF, I leave a 1 in my parentheses as a placeholder. Just to say like, hey, there was a term there, so I'm going to put a 1. Okay. All right, any confusion with that so far? Okay, so the parentheses are not identical, therefore the parentheses are untouchable. But I can look at the GCFs in the front, and what do I notice about those? Cancel. Okay, so in my reduced form, I have x squared minus 6, x plus 1. I can cancel out the x's. Negative 6 over 1 is negative 6. There we go. We saved those puppies. Look at you guys. Okay, last one was just a trial round. You only stabbed the puppy just a little bit. It wasn't like all the way. It didn't hit any organs. It was just like a flesh wound, you know? Just like stabbed it a little bit just to see. And then you said, no, I don't think I want to stab this puppy after all. You know what I'm saying? We saved it. It's fine. We saved it. We saved it. Whew. Okay. Next one. It's written as numerator over denominator. Is it in the correct order? Yes. Our next step, we start canceling things. Negative 16 divided by 4 is negative 4. We say no. Okay. So what are we supposed to actually do next? We're supposed to factor. What type of factoring do we have on the top? Difference of squares. Now, why can't we take an x out? On the top, why can't we take an x out? The 16 doesn't have an x. Does that make sense? The 16 doesn't have an x. So we can't take an x out on the top because the 16 doesn't have an x. So the top is difference of squares. We're going to have 2 sets of parentheses, one with a plus, one with a minus. X plus 4, x minus 4, right? Because the square root of 16 is 4. Okay. And then on the bottom, we have to go back to our highlighting here, right? If it starts with a negative, we have to factor out a negative 1. Take out a GCF of negative 1, okay? So for the bottom, it starts with a negative. I'm going to factor out a negative. You can put the 1 with it or leave the 1 invisible, but I'm going to take a negative out. When I divide by a negative, what is my new first term? X. When I divide by a negative, what's my new second term? Negative 4. Okay. Do I have any parentheses that are identical? Yes. X minus 4 and x minus 4 can cancel. So if the parentheses are identical, they can reduce. So my final answer is x plus 4 divided by negative 1. You could leave that as an answer, but on a multiple choice test, you would not see that as an answer choice. It just wouldn't be there. So is it possible to divide both of these by a negative? Yes. What would we get if we divided both of them by a negative? Negative x minus 4. Okay, that would be the more common answer, but this answer is not wrong. Okay, how are your brains feeling? So what are we basically doing today? Factoring and canceling. Factor, cancel. Factor, cancel, but don't kill puppies. Okay, let's try the next one. How do we feel about the order? Fix it. So we like the numerator over denominator, but we don't like the order. I think the bottom looks good, so I'm going to rewrite the bottom. What should I do with the top? Okay, I'm going to start off by doing this, right? Was this a good first step? No. Okay, don't kill a puppy is the first step. Okay. So it's numerator over denominator. It's written in the correct order. I didn't kill a puppy. Now what should I do? Factor. Okay, so I'm looking for what multiplies to negative 5 but adds to negative 4. Negative 5 and positive 1, okay. And I'm looking for what multiplies to negative 15, adds to negative 2. Negative 5 and 3. Okay. So on the top, I have x minus 5, x plus 1. On the bottom, x minus 5, x plus 3. Okay. Do I have any factors that are identical? Yes. What are they? X minus 5s. Okay, I can divide those. And then what is my final answer? X plus 1 over x plus 3. Can I cancel anything else? No. Not unless I want to be a murderer. Okay. How do your brains feel about that? Great? Okay. So here's what I've got for you. All right, let's work on a few of these first couple problems. So if we look at number 3, 12 and 54, what number can you divide out of both of those? 6. So 12 divided by 6 is 2. 54 divided by 6 is 9. Okay, if we look at the M's, does the top win or the bottom win? The top wins. And how many does it win by? 2. Okay, so the top wins by 2, so it's 2m squared over 9. Okay, let's look at number 6. 80 over 20, what can we divide both of those by? 20. Okay, so 80 divided by 20 is 4. 20 divided by 20 is just 1. If I look at the x's, does the top win or the bottom? The bottom. How many does it win by? 1. Okay, so 4 on the top, 1 on the bottom, x wins by 1. Or you could just write 4 over x. Okay. For these ones that say state the excluded values, we're going to ignore that. I decided to do that later in the unit. Okay? The next section, number 9. Yeah, you can still simplify those. Okay, look at number 9. Can you cancel out the parentheses? Okay, they're not identical, so you can't even touch them. Nothing in the parentheses can be touched. But look at the GCFs. 6 and 6 can cancel. X and X can cancel. Okay, 3x plus 4. 5x plus 6. Okay. Let's look at number 11. Yeah. Let's look at number 11. How do you feel about those parentheses? Cancel those. How do you feel about the GCFs? Cancel the ends. Now, the 8 and the 10 can't cancel, but can they reduce? Yes. So they're both divisible by what? 2. Okay, divide 8 by 2 to get 4. 10 divided by 2 is 5. So my final answer, 4/5. Okay. Number 13. Cancel the first parenthesis. N minus 10s, those are identical. Okay, what's our final answer? N minus 4, N minus 5. Okay. Is there anything on the front side of the page that you don't feel good about? Front side of the page, we got it. Front side of the page is good? Okay, let's flip to the back. Okay, not very many problems on the back. Let's do number 16. Number 16 looks crazy. It's already written as a fraction. It's written in the correct order. Is it ready for us to cancel things? No. It needs to be factored. What type of factoring? 2 terms. It's GCF. GCF factoring. What's in common between a 27 and a 72? Divide by 9. And if you're not sure, just a reminder of what your calculator can do. If you hit the math button, go over to number, and hit 9. And then 27, comma 72. Do you guys remember doing that at the beginning of the quarter? We did this. The calculator will tell you what the GCF is. It's 9. Okay, 9. What's the GCF between m squared and m? M, okay. We got to write our leftovers. 27 divided by 9. 3m. 72 divided by 9. 8. Okay. What's the GCF between 63 and 36? Ooh, 63, 36. Also 9. Okay. And also an m, right? What is 63 divided by 9? 7. 7m minus 4. 36 divided by 9 is 4. So can we touch the parentheses? No, the parentheses are not identical. But what can we cancel? The GCFs. The 9s can cancel. The m's can cancel. So 3m minus 8. 7m minus 4. Okay. Down here, I'm going to scribble out, state the excluded values. Okay. Is there anything on the back of the page that we feel intimidated by? No? Okay. So I think maybe if we don't have a video tonight and the factoring is extra credit, can we do this whole sheet? No video, factoring is extra credit? Okay, let's do this whole sheet for homework.